So, all right. So, as I was saying, if you go on a Blackboard under assignments, homework, chapters 11 through 14, there will be a PDF there. If you open it up, then you will have your name followed by a list of problems from that particular chapter. So you'll see something like 13.43, and that means chapter 13, problem 43 has been assigned to you, if that's under your name. And I would like them by Thanksgiving. So this will be a quiz grade. And it is to be handed in. Any questions at the moment? Any other questions at the moment?
So if that's going to be a quiz grade for those homework problems, will we not do like the regular homework for those chapters?
Right, correct. So this is in lieu of an in-class assessment. All right. We last left off talking about pressure. And what is pressure?
Mass over volume?
That's density.
Oh, okay.
All right, we'll use that at some point, so I'll write that up here for now. So density is mass over volume. All right, so pressure.
Is it force over acceleration? Force over acceleration?
No.
Force over area.
Yes. The other A. So it's a force per unit area. If we're dealing with SI units, the unit of pressure should be, well, would be newtons per square meter. And then what's the one word unit in the international standard for pressure?
Is it PA?
Yes. Capital P, lowercase a, which stands for
Pascal? Is it Pascal or Pascal?
I always pronounce it Pascal, but your pronunciation might be correct also. I guess the person's capitalized, the unit doesn't have to be capitalized. So that's the standard, international standard for the unit for pressure. And I went through an example of how much pressure my feet were exerting on the ground. And so let's take it that one step further. The stiletto heel. So, any of you worn a stiletto heel before? None of you? Huh. All right, then I'll have to go off memory from previous classes. I think it's bigger than it usually is. Manal, any experience wearing a stiletto heel?
I guess. Not like that.
I was wondering how big the heel is.
Oh, 6 inches.
The diameter of the tip.
Oh. Lord.
Is it about that size?
Yeah, I guess. Half
Alright.
an inch.
Well, we'll go with this, if that. So, can you penetrate skin with it? Well, if you believe the movies, you can. Let's find out if that's true. All right, so if that's the size of it, there we go. My diameter is, that's a crude approximation here, but my diameter is about 1.1 centimeters, which puts my radius at 0.55 centimeters, which is 0.0055 meters. So we'll take average person. Average adult in the US has a mass of somewhere around 70 kilograms. So let's assume this person is wearing a stiletto heel and basically is standing on just one heel. How much pressure is being exerted now? Well, if that is person, this is my drawing of a stiletto heel right there. That's a shoe. Sure, we'll go with it. The weight, we have two forces acting on the person. We have weight acting down, we have normal force acting up. Let's just assume that the person is balanced perfectly on this heel and the heel doesn't break. The person is balancing perfectly on this heel and in equilibrium. So if the person is in equilibrium, what can you tell me about the forces?
The net force is 0.
Okay, so therefore y is equal to the weight, the normal force equal to the weight, which is equal to mg. And so we have a mass of 70 kilograms. Let's assume it takes place somewhere generically on Earth. And we end up with thank you. Newtons. So the pressure that person is going to exert is the force, 686 newtons, divided by the area. Well, I basically have a circle here with a radius that is tiny. What's the area? How do you find the area? Or what formula would you use to find the area? Yes, it's a circle. So pi r squared. So pi times 0.0055 squared. And what you get?
9.5 times 10 to the negative fifth.
Is that what you said? Units?
Meters? No.
Not if you stop there.
Meter squared.
Yes, because you squared it. That's meters inside the parentheses, and the meters get squared also. All right, so divided by 9.5 times 10 to the negative fifth meters. So we can now find the pressure being exerted.
I'm getting 7 million.
Okay.
Okay. 7,221,052.632.
Did I get all the, that's a 2 there. Is that what you said?
Yes.
Okay. Anyone else get the same thing? Same thing?
Mm-hmm.
Okay. Units? Yeah, pascals, or newtons per square meter. Oh, oops. I forgot my square right there. Pascals. All right, so we have over 7 million pascals of pressure here. The question is, can that penetrate skin? Well, I've looked it up. Because what's the use of doing a violent problem unless you've done the research? Or somebody's done the research. All right, so skin will be punctured at 100 psi. This is the puncture pressure for skin. So the question is, first off, what is PSI?
Pressure per square inch.
Close. You got the last bit. It's the P is not for pressure. Or that P is not for pressure.
Pascal.
No.
Curiosity.
I think inches is not metric. So we're dealing with a force that is not metric.
Pounds?
Yeah, it's pounds per square inch. So when you're filling up your tire and you're supposed to fill it up to 32 psi or whatever the number is for your particular tire and car, that's pounds per square inch. And that's the common unit we use around here. So I have the value in PSI, we need to somehow get it into pascals. So instead of doing the straight up conversion, we will convert the pieces. And what I mean by that is, what are the chances this will be dark enough to show? Oh, I've seen worse. So it's pounds per inch squared. So first we need to get pounds into newtons. How many pounds in a newton or newtons in a pound?
Is that like 4.6? 4.6?
Close. Do you know which is which? Is that pounds per newton or newtons per pound?
Newtons per pound.
All right. So it's 4.4, 4.448, and let me double check that. Yeah. Newtons per pound. So that will get rid of my pounds here. So I have newtons on the top. Now I need to get inches into centimeters. How many centimeters in an inch or inches in a centimeter? It's a little bit under that. It's 2.54. So inches are on the bottom. So with centimeters on the bottom, it's 2.54 centimeters per inch squared. And ultimately, we want meters. So how many meters in a centimeter or centimeters in a meter?
100 centimeters per meter.
Right? And since we want meters on the bottom, so it's 1 meter here, 100 centimeters on top. So my square inches here will cancel out with those inches there because it's squared. And my square centimeters here will cancel out with those square centimeters. And so our math problem is just 100 times 4.448 divided by 2.54 squared, and then times 100 squared. Manal, you have the look of, you have an answer, but you don't believe it's true.
I don't know.
What'd you get?
689,431. Point 38.
And units?
Pascal.
Yep. Or newtons per square meter, if you want to go the long way. All right, and that happens to match what I have written down there, so. All right, so we have a little under 700,000 pascals, or a little under 700 kilopascals, is the pressure it takes to puncture skin, and indeed, the stiletto heel will do it with plenty to spare. You have more than 10 times the amount of pressure you need. Thus, the occasional realism of the occasional murder mystery that you'll find when someone dies from a heel. Usually to the head or chest. I'm not promoting violence, just physics naturally lends itself towards it. All right, any questions before we start talking about liquids? So let's do the bit that actually relates directly to the lab. Went over, at least sketched over it on Friday. So we will repeat some of it. So today is it's the multiple choice day, test day. Yeah, there's time. Sorry about that. Should have jumped straight into that bit. That test that you took the very first day. This is the big one. This is for the grade. Before we get into before I bring it out, any questions in general over the course? All right, let's do it. I'm going to go grab them. Remember, it's 30 multiple choice questions. Please have a separate sheet of paper. If you don't have paper, we've got plenty up here. And when you are done, hand it in. And it usually takes about 45 minutes-ish to do. So when it is over, I still plan to do class.